Chapter 4, 5 and 6 deal with probability, with chapter 4 being the basics of probability. Chapter 5 is discrete probability distributions. And discrete probability distributions is when you have, here are the chapter files that you need. The PowerPoint file, make sure that you download that and follow along the PowerPoint slides as you watch this video. And then we have the formulas in a PDF file. Formulas in a PDF file, make sure that you print that out. And of course you have the Excel shell file, download it, open it in Excel and do each and every problem that I'm going to be illustrating in the Excel, repeat that and replicate all of those activities in your Excel shell file that you have saved in your computer. Okay, in this chapter we're going to learn about probability distribution, the computing expected value and variance of a probability distribution, and then we're going to look at two specific discrete distributions that have formulas for probabilities, binomial and Poisson distribution. Okay, first let's define what discrete and continuous means, and we have already seen this once before. Discrete is something that you count, and continuous is something that you measure. So count will be how many classes are you taking, or how many pairs of shoes you have, how many customers call within a period of say 15 minutes. These are things that you count. And if you associate probability for each of those possible numbers, then you have a probability distribution for a discrete variable. Continuous, on the other hand, is something that you measure. It's like weight and height and time and temperature and that kind of stuff. So probability distribution is associated with continuous variables is in the next chapter. Right now in this chapter we're going to talk about discrete random variables only. So types of variables: discrete variable, where you have specific points in a line and you have a probabilities associated with each one of them. And then you have continuous, where there is a continuum and there is no specific one particular value. It will be a range of values. So discrete variables can only assume a countable number of values. Okay, the number of possibilities are countable. Like in the roll of a die, there are 6 possible outcomes. Toss of a coin 5 times and reading how many times you get heads will be either 0, 1, 2, 3, 4 or 5. Or if you're talking about number of customers calling a telephone line, okay, there the possible values are x equal to 0, 1, 2, 3. You still count, but there is no upper limit. Like in the case of tossing 5 times a coin and reading number of heads, you can only have either 0, 1 all the way through 5, and that's it. The 5 is the upper limit. Whereas when you're talking about number of customers calling in or walking in, so there is no upper bound, but you still count. So these are discrete variables. And if you associate probabilities for each possible value, okay, two things must be true for a probability distribution. One is, on the one hand, you must list all possible values, okay, for the variable. And then you associate probabilities for each possibility in such a way that when you add all the probabilities, you get 1. Okay, that is the complete sample space. Okay, so each probability must be between 0 and 1, and when you add all the probabilities, you must get 1. Then only it is a probability distribution. Okay, if you add up all the probabilities, either it falls short of 1, or if it falls short of 1, then you're missing some probability. If you go greater than 1, then you have not assigned the probabilities properly. There are some joint probabilities that are lurking in there. So you have to make sure that you list only the possible values, but all possible values, and the probabilities all sum to 1. If that is so, then you have a discrete probability distribution. So something like this: you have possible values of x, and for each possible value of x, and you have a probability associated with that. Now if you have a complete and valid discrete probability distribution, then if you multiply each possible value with the corresponding probability, like the 0 times probability, 1 times probability, and so on, and add them all up, then what you get is called the expected value of x, which is another name for mu, population mean mu. So population mean mu is given by the expected value of x, where you take each possible value of x and multiply by the corresponding probability. Make sure that this is a valid discrete probability distribution. Okay. Now you can define one more thing, which is the measure of dispersion, and you can also compute variance of that discrete variable by taking each value of x, subtracting the mean mu or expected value x, squaring that, and you multiply that value by the probability. Okay. And of course, sigma is the square root of sigma squared. Here is an example where these are the possible values of x, and you've already computed E of x in a previous slide. So 0 minus 1.4 being the mean of x or expected value of x, and 1 minus 1.4, 2 minus 1.4, square the difference, okay, and then you take that squared difference, multiply by the corresponding probability, and add them up, and you get your variance of the variable. And you take a square root of that, and you get the standard deviation. Now let's look at an example in Excel.